Severe weather analysis for January 24th, 2023, as the Storm Prediction Center does have an enhanced risk of severe weather across the Gulf coastal states. This does include the potential for strong tornadoes south of Houston, Texas, all the way to New Orleans, Mobile, Alabama. We also have some heightened damaging wind probabilities as well. So in this video, we're going to look at the characteristics of the atmosphere which may support this event coming together. And we're actually going to start off with the current mesoanalysis because something of interest is that because we've got high pressure off to the east, we've got some dry air, some colder air, and easterly surface winds, we're not seeing very good moisture quality along the Gulf Coast to this point. We've got dew points in the upper 30s to mid 40s range, which we would expect to see higher, but they are not very high at this point. So we're going to have to rely on moisture advection, and that could change as a result of this very potent upper level trough you see currently in a positive tilt. But as we play this forward, it does start to mature, such that by tomorrow evening, 00Z, we are now into a negatively tilted wave. We have very strong, potent vortex here at the base of it. Height gradient is amplifying over this region here, so the mid-level jet is strengthening. The upper level dynamics associated with that are getting stronger, and this gets even more amplified as it moves toward Arkansas in the evening hours. Now, the dynamics associated with that are going to yield pressure falls. We're initially seeing the surface low over parts of southern Texas, fairly well-developed low with a warm front off to the east. By 00Z, that has moved into parts of Louisiana, possibly the Louisiana-Texas coastline, or border, I should say, and then into northern Mississippi during the overnight hours. So we have the surface low moving off in this general direction as this occurs, and the warm front lifting slightly northward. Now, I did mention the limited moisture quality at present because that is going to limit the spatial extent of the severe weather risk, thankfully. So we're really, and this is represented here in this forecast model, we really don't have tremendous moisture quality to this point. But once that surface low develops and we do get the pressure falls, the pressure response to that is going to bring higher quality moisture northward along the Gulf Coast. And you can see here, we might have dew points into the mid-60s, maybe upper 60s even, as we head through the period. Louisiana, now by this point we're looking at 03Z, according to this particular model. And then we move that over into parts of southern Alabama. Still 66, 67 degree dew points, that is pretty good. And with that, we do have modest buoyancy. Surface-based CAPE, you can see initially, starting out in the coastal Texas area, maybe perhaps into this area, modest buoyancy, 500 to 1,000 joules of surface-based CAPE, and playing that forward, we see this surges a little bit again as we get that low-level jet amplify into eastern Louisiana and southern Alabama, again approaching 1,000 joules at most for surface-based CAPE. This is a low CAPE, high shear setup that we're dealing with, so limited buoyancy, but still significant severe weather potential, and part of that is this mid-level jet. I mentioned earlier that height gradient is amplifying. We are getting stronger flow as that jet rounds the base of the shortwave. Look at this, we're amplifying to over 100 knots, then we get over 110 knots, I believe, in some places, as this spreads eastward into the overnight hours. So because of that, we're introducing very strong wind shear all through this region, and it is to a degree perpendicular to the initiating boundary. That's important for storm mode. And as we get those pressure falls getting really strong associated with this low pressure system in the lower portions of the troposphere, very strong pressure response yielding an incredibly strong low level jet here. We see that amplified during the evening hours. 00Z, we're up to 70 knots in northern Louisiana, and further into the evening we're up to 80 knots even across parts of Mississippi, and the effect of this is very strong, and some of this is going to be north of the warm front. That is important to note. Again, most of our warm sector is going to be in the southern portions of these states, and most of the high quality moisture is going to be in the vicinity of the Gulf Coast. So for this particular model, we're going to look at 0 to 1 kilometer SRH, that's storm relative velocity, overlaid with surface-based CAPE. So the red lines down here, that's surface-based CAPE, and where we have any of that, we do have surface-based instability. Playing this forward, we do see that move northward into the afternoon hours, such that we do have an overlap of appreciable instability here and large values of 0 to 1 kilometer SRH, courtesy of that low-level jet. We're looking at values that could be 300, 400 plus meters squared per second squared in the afternoon, and that does progress into the evening hours. We're going to move this forward again. We do maintain instability. Those pink values are 400, 0 to 1 SRH. We do maintain some slight buoyancy that is going to maintain these updrafts, especially along the Gulf Coast area. That's why the coastal regions are probably going to be the highest probability, and as we head into the overnight, this shifts over to the western Florida Panhandle. Now, to look at a couple of soundings, this might be a little bit contaminated, so it might not be truly representative of the environment, but we're going to get some generalizations, I should say, of this environment that we could be seeing. First of all, very deep, moist layer in close proximity to the Gulf Coast, high relative humidity associated with that, really low cloud base heights, and downdrafts that are descending in this. Not tremendously energetic, so we don't have very high D-CAPE, but that does increase RFD buoyancy if we have discrete storm modes. And so you see that's appreciable instability, especially in Texas. We might see some of the best instability in Texas. That positive area is fairly appreciable for the time of year. And obviously your attention is probably drawn to the upper right of the screen. This tremendous curvature and length in the low-level hodograph, indicating very strong speed shear, strong directional shear, and as we head into the evening too, the pressure falls at the surface are yielding a southerly or even southeasterly component to the surface wind, which increases the directional wind shear, and that increases the curvature of the hodograph. So both of these are from the NAM. The first one, this sounding here, that is from the southeast Texas area, south of Houston. This is approximately around Mobile, Alabama. This is later in the evening, and we're maintaining those same characteristics of the atmosphere. The moist layer is very high in relative humidity, low cloud base heights, appreciable but thin CAPE profiles, which will yield some updraft potential, and tremendous hodograph curvature, tremendous speed and directional shear, courtesy of that very strong low-level jet. And you can see down at the bottom, this fits in a parameter space that could support significant severe weather, including potentially some strong tornadoes. And we're going to look here at simulated reflectivity. I do want to mention here, kind of give a shout out to Trey Greenwood of Convective Chronicles. Go check out his video in this. It is much better than mine. He is a lot better at this than I am and gives very in-depth descriptions. You should certainly see that if you have not already. But we're looking here, we're going to take the HRRR and see a generalization of what might happen with this environment. Now, because we have a high relative humidity, low convective inhibition air mass moving northward with this, we're probably going to see a lot of storms develop with the upper level dynamics coming in. So that's represented here by 15Z, so we're heading into the late morning hours. A lot of precipitation and a lot of storms trying to develop across Texas. That might interfere with the storms, and that might actually decrease the tornado potential a little bit, so that's a good sign. But the concern we have is this. As we head into the afternoon, tremendous convergence along that front, a lot of forcing yields some enhanced convective updrafts, which with these wind shear vectors kind of going like this in the deep layer across that boundary, we could have a broken line. And downstream of that, because of the moisture advection, localized pressure faults, and confluence bands, whoops, that was unintentional, we could have some discrete storm modes develop ahead of that. So we're looking in this region even, south of Houston, perhaps up to the Houston metro area, concerned for possibly some discrete storm modes trying to fire. But we have a lot of storm coverage along that line. It organizes into the evening hours, spreading into East Texas and southern Louisiana. Damaging winds are likely with this, and embedded tornadoes. Several tornadoes are possible given that wind shear environment. And I want to play this forward still as we head into the overnight, because that is a concern. You do want to have a way to receive warnings here, because this is certainly a concern for the overnight threat of this. You see a little bit of storms trying to develop along the Gulf Coast, perhaps ahead of this line. I'm sorry about that. That could be some discrete modes, but also we're looking at a lot of spin-ups along the line being possible, some enhanced wind damage being possible as well. So severe weather is likely across this region this afternoon and tonight. Have a way to receive warnings and continue to monitor further updates on this impactful severe weather risk.